Hey guys, welcome back. In this lesson, we'll be building our API from scratch using a framework called Flask in the language Python. But before we do that, I really need to explain you the concept of having multiple endpoints to access an API. And to do that, we'll be revisiting our example of a bank that we discussed in the previous video. So just just a quick recap. You are this person and you go to the bank and you visit the bank, and this respondent over here is there to take your requests. You hand over the check to this respondent, who then goes to the bank account, comes back with your cash, and hands it over to you. Now, what if you wanted to do multiple different things in a bank, like you wanted to encash a check, deposit money, or ask some questions? In a typical bank setup, you would have three different desks for that and three different respondents for each responsibility. So, if you wanted to encash a check, it will be handled by this guy. If you wanted to deposit some cash, it will be handled by this woman. And if you wanted answers to some queries, you can go over to this counter and get them cleared. Now this translates into our API example really well, because in our API we want to do multiple things, and access the same database to do that. So heading over to our API example, we would have a list of endpoints. We call each of these responsibilities as endpoints. So each of these endpoints performs a specific thing. So if you wanted to list all tasks, your front end will visit this endpoint, which will trigger a request on the server to list all the tasks. It will then fetch a list of all the tasks and return it to your front end. Similarly, for anything you wanted to do. So basically, in our to-do list application, we'll have four different responsibilities. The first one will be list all tasks, because you will be listing all the tasks when you select a task list. Then it will you will have then you will have to create a new task, which is the create task endpoint. Then if you wanted to create a new task list, that will be the create task list endpoint. And if you wanted to update the status of a task, which is basically mark it as completed or incomplete, you will visit the update task endpoint. So this is basically what our API is going to look like. These are the four endpoints that we'll be working on. And to make things clear, I want to discuss the data structure or the data models that will be involved in our to-do list application. So we have two data models basically that are composed inside our to-do list database. One is the task lists model and one is the tasks model. Both of these are basically SQL tables, and they have specific columns. In the SQL world, these things are called columns because they are present in a table. But in a programming language context, these are called properties or attributes, because they represent certain attributes of an object oriented program, of an object in that programming language. So we have two objects, the task list object and the tasks object. The task list object has two attributes, which is the name of the task list, which can be anything, home, work, etc., and the tasks object, which is basically the object that represents each checkbox, each to do that you have to complete. So it has four properties: the text, which is basically the text of the task, which could be buy groceries, take the dog for a walk, something like that. And completed is a boolean value, and boolean means either true or false. So completed is a boolean value which can be true or false. If it is true, that means you have completed that task, and if it's false, that means you have not completed the task yet. Then we have the list ID. Now the ID that you see over here is the list ID. So each task is associated with a list, which means that a task list contains multiple tasks. And the way you associate multiple objects to a single object is by an identification number or a string or whatever that identifies which parent object it belongs to. So the list ID attribute over here tells that this task object is a part of this task list. So if the ID over here is 1, then this task's list ID will also be 1. And this object also has an ID, and this is required to identify this specific task. So that's for our data models, and we'll start coding our API now. To do that, we'll head over to our terminal application. Then we move into the desktop because we'll be creating our then we'll move into our desktop to create a new project. So cd desktop, and in the desktop we'll create a new directory. To do that, we'll type in mkdir and name of the directory. So we will name this to do list backend, which is to do list be, and we'll press enter. So it creates a new folder for us called to do list be. As you can see over here, we have this to do list be folder. Now we will be creating all of our project files in that folder. So we will move into the to do list be folder. Sorry for that. And in that folder we create a bunch of files and folders, actually. And in this folder we create a new folder called venv, which will represent our virtual environment. If you would have followed the lesson where we installed our dependencies, you would remember that we installed a virtual environment manager, and it has a very simple purpose. Virtual environment is meant to keep the dependencies of this project contained in this folder, so it does not conflict with the dependencies that you've installed globally. So if you've installed multiple Python packages globally, then they won't have conflicts with the dependencies involved in this project, and that makes it a lot easier to have different versions of different dependencies for different projects, so you don't have any conflicts with the globally installed packages. So what the next thing you need to do is create a virtual environment. To do that, you'll type in virtual env and then space venv. So this will create a virtual environment for you in the folder called venv. I'll wait for it to set up. Now that it's set up, we have, if we ls in this directory, we'll see that we have a folder called venv. Now the next thing we want to do is to move into the venv directory. So the next thing we want to do is to So the next thing we want to do is to activate the virtual environment, and to do that we'll just run the binary file inside the venv folder. And don't worry if you're not understanding what I'm saying, you just need to run this command to activate the virtual environment, which is dot space name of the virtual environment folder, which is venv slash bin, which represents the binary files, and inside the binary files we have a file called activate, and we will activate the virtual environment. Once the virtual environment is activated, you will see this venv before each of your terminal commands, so you know that it is active. And if you want to deactivate it, just type in deactivate and press enter, and you see that the venv precursor gets removed. Again, we'll activate it because we need to install our dependencies. So there are a few so, so there are a few dependencies we need to build this API and for deployment later. So we will install all of these dependencies at once, and I'll explain what each dependency does one by one. So to install a new dependency, we will type in pip and install, which means that we are using pip, which is like the npm of the Python world, which basically means that it is a package manager for the Python framework, for the Python environment. So we'll use pip. So the command to install a package is pip install and the name of the package. So we want to install Flask because we will be building our API in Flask. The next thing we want is scicop G2. Now don't worry about the name of this package. It's just a package that you require to connect your database to the Postgres database in your local machine, and on our deployment server that we'll use later on. The next thing we want is Flask underscore SQL alchemy, and this is another module or package that is required to connect to contact the database using Python code. So it is also called an ORM, which is the full form is object relational mapper, which means that it which has three words: object relational mapper. So object means the object in the Python programming language. Relation means the table in the SQL database, and mapper means it connects both of them. So you can access different table entities which are stored in SQL through objects in Python. So that is why we will need Flask SQL Alchemy. Another package that we need is called Flask underscore cores, and this is used to allow different clients to make requests to this API, which means that uh, the full form of CORS is cross origin resource sharing, which basically means that our front end can be decoupled completely from this API, and it can be hosted on a complete different place, and it can still make requests to the backend and retrieve the resources that we need. So cross origin resource sharing. So these are basically the four modules in Python that we'll be requiring to build our Flask application. And once you have I'll just remove these commas because they are not required. So once you have typed in this command, you just press enter, and it will install all of these dependencies in this specific virtual environment. I'll show you the difference. So for it to show to see all of the, now I'm going to show you how a virtual environment works. So I will show you, so I will run to so I will run the same command inside the virtual environment and outside the virtual environment, so you'll be able to understand what I'm saying. So let's run pip freeze, which is a command that basically lists all the Python modules that you've installed, and press enter. So you see we have a list of all these packages that we've installed along with their versions, right? Now this is running inside the virtual environment. Now I will deactivate the virtual environment for the time being, and then run pip freeze. Now as you can see, I have a much larger list of Python modules that I have installed on my computer that are returned when I type in pip freeze, which is exactly what I was trying to teach you. The virtual environment basically enables you to install specific modules with specific versions specifically for the uh, this project directory. So we will activate venv again. So we will type in venv bin activate and press enter. Now that we have venv activated, the next thing we want to do to add to our project directory are a few files. The first will be, and to create a new file you use the touch command. So tuch app.py, which will be the Python file which runs our application. This will be the file where all of our code lies. All of the business logic and API code will lie on in this file. The next thing we want is a requirements .txt file, which is basically a file that will contain a list of all the dependencies that we require for this project. The third file will be requiring later on is a proc file, and to do that you just type in capital P ROC FILE. Now this file will be required when we deploy our code to Heroku, so you don't need to worry about it right now. The next thing we do is press enter, and it creates all the files for us. So if I type in ls, we have a directory structure. We have a directory. We have a directory structure set up for us. So we have a proc file, we have a app.py, we have requirements.txt, and we also have venv. So the proc file. So now that we have set up our directory, we need to list all the. So we will open this directory in our Visual Studio Code. So you will type in code space dot, which will open Visual Studio Code in this directory. I will maximize and bump up the size a little bit. Now when I click requirements.txt, you click so when I click requirements.txt, you see that it is an empty file and doesn't contain anything, but we want it to contain all of the dependencies that we had installed. And if you remember, we used the command called pip freeze to list all the dependencies. Now we want to save the output of this command in the file requirements.txt. To do that, it's very simple command line functionality. You type in pip space freeze, and for the output you type in the greater than symbol and the name of the file. So we'll type in requirements.txt. So if I press enter, it doesn't output the source. It doesn't output the list of dependencies in the terminal. But if I see here, I now have a list of all the dependencies that we require for this application in this file called requirements.txt. Now that we have that set up, we will start coding our app.py file. And the first things that and whenever working with Python, the first thing that you want to do is to import all the necessary modules that you would require later on. So the first thing we want to import is Flask. So to import Flask, we import the Flask class from the Flask module. To do that, we type in from Flask with a small f. We import capital F Flask, which is the class we need to use to instantiate Flask objects. Now, the next thing we'd require is a module called JSONify, which is basically used to return JSON objects, JavaScript objects over the API. And the next thing we'd want is a request module, because we require this to meddle with the request that we are receiving on the API. So we have these three uh, we have a list of three modules that we have imported for our application. The next thing we want to do is to create an object that will hold our application. This basically allows us to do a lot of things with the Flask class. So to instantiate an object, we type in the name of the object. So we will name it app and equal to Flask, and open brackets, close brackets. In this, we will type in this we'll type in the name of this directory, and to do that we will type in underscore underscore name underscore underscore. So this will create an Flask object with name being to-do list backend. So now that we have an app set up, we need to run this application, and to run this application we need an endpoint to serve something on. And to create an endpoint, we will basically just type in at app dot route. Now this is a some now this is a little advanced Python syntax, because it is this is called a decorator, but I will explain the basic functionality of this in this lesson, and you'll be able to follow. So when I type in app.route, uh, uh, and inside brackets I type in the route or the endpoint where I want to entertain the request, it creates a wrapper function, which is basically this decorator. So this anything that is preceded by an app by an @ sign is called a decorator. So it creates a wrapper function. So this wrapper function it wraps another function called the handler function. So let's say hello, and inside this hello function we return something. So let's say we return hello world, right? So what this code is basically doing So what this code is basically doing is that it's creating a URL endpoint and wrapping the immediate function inside it. So that means whenever this endpoint is visited on your browser or on the client wherever the request is made, this function responds to that request. So whenever we visit slash, uh, for example, our application will lie at http www.todolistbackend.com slash. So whenever we visit this slash, this function will return. This this function will get fired, and this function will get triggered, and we will see a return hello world on the screen. Now right now, if I try to run this application, it won't run, because we need to tell Flask that it needs to run this application inside the main function. And to do that, we need to tell that if the name equal to main, we have to put this in quotes. If name equal to main, we will type in app, which has a function called run, and inside run we type debug equals to true, which basically sorry, d with a small debug with a small d, and we'll save that. So now that we have here, so now Flask knows that whenever the function name, whenever the constant name is main, it will run the app, and by default it runs the app in port 5000, which means the app will be live on localhost slash 5000 when you visit on the browser. So we will save this and we will try to run this application. And to run this application, we will type in Python, which means we need to run the Python file and name the Python file, which is app.py in this case, and then we will press enter. As you see, it shows that it is running on HTTP this, and which this IP basically means localhost. This is your computer 127.0.01, uh, 127.0.0.1 is your computer, and it is live on the port 5000. So to check that, we will visit the browser, and in the browser we will open localhost comma colon 5000 and press enter. Now as you see, when we go and visit the base URL, which is basically a slash, we get a hello world on the screen. So this is because when we are visiting this route, basically slash uh, nothing, it fires this function and returns hello world. So to check whether our API is actually working, we will change this route. Let's say you enter your name, so I enter my name, which is Abhishek, and hit save. Now when I visit this base URL, it won't return anything because that URL is not being handled. But if I visit slash Abhishek, and you can enter your name here and press enter, I see a hello world here. So this basically means that it is handling a slash Abhishek endpoint. So that's that. We will save the application here. Now that we have our Flask application up and running, the next thing we want to do is to uh, import a link to the database and connect our application to the Postgres database. To do that, we need to import a few packages. One of them being from from Flask SQL Alchemy. We will import SQL Alchemy class, which is a capital CQL and an alchemy with a capital A. So we will import that class, and to instantiate the database, like we created an app object to instantiate the app, to instantiate the database, we'll create a database object, and we can name it anything, but for convention we will name it DB equals to SQL Alchemy, because this is a class now, and inside this SQL Alchemy object we'll pass in the app object. So this basically, this line means that we are creating a database using SQL Alchemy for the application we have just created. So this is the connection to this data. So this is how we instantiate the database object. Now the connection to the database can only be made if we update a config property of the application object. To do that, we will type in app.config, and because this is a Python dictionary, if you would have followed the basics of Python video that I linked before, this is a Python dictionary where we pass in key value pairs. So in this case, we need to assign a key to a specific value, and in this key, the name of the key is SQL Alchemy underscore database underscore URI. Now all of this needs to be in complete capital letters, so that's, so try and follow that. Now it needs to be equal to, so this key in the config object needs, in the config dictionary, needs to be equal to some port needs to be equal to some uniform resource in some uniform resource. So needs to be associated to the URL where the database is live. If you would have installed Postgres, you can open Postgres, and I will show you that I have created a database called to-do list, and the to-do list database is what we'll be using to create our tables. Now if Postgres is running on your local machine, the URL where your Postgres database will rest is somewhat like Postgres QL colon slash slash localhost and the name of the database you have created. So I have created a database called to-do list, so I will connect to that to-do list, and then I will save this file, and then see that it reloads the application without an error, which basically means that we were successful in connecting our application to the database. The next thing, now that we are connected to the database, the next thing we want to do is to create the data models. And to create the data models, we will follow very simple method. And if you remember, a few minutes back I talked about something called an ORM, or an object relational mapper. And an object relation mapper basically maps a Python object to a relation, which is another name for a table in a database. And objects in Python are created, and objects in any object oriented languages, in any object oriented language including Python, are created using something called classes. And this you would have learned about classes in the video I linked before. So to for each data model we have a specific class. So we will type in class, which tells us that we're creating a class, and the first data model we'll be creating is a task list. And in the brackets we will pass in the class that it will be inheriting from, which means that it will be a type of this class. So I will pass in db dot model, which basically means that the class task list is a database model. It is inheriting certain functions from a database model, and that's how it works basically. Now that we Now let's quickly look at our database structure, and to do that I will open this presentation. In this presentation we have this database structure. So we have two data models here, task lists and tasks. Task lists has two properties, name and ID. So we will start building our task list model. First we will define the table name, which should be underscore underscore table name underscore underscore, which tells that these two following underscores basically means that this is a constant. So we will change the table name constant and set it to we will name our table task lists, right? So this will be the name of our table. The next thing in a the next thing we want to do is associate attributes to this table. So looking at our data model, we have two attributes, name and ID. And ID is of type string, id is of id is of type integer, while the name is of type string. Now to create these attributes we will just assign variables to assign vari to we will create two variables inside this class. So id is the name of this variable, is equal to db dot column, which basically means that this is a column in the database, and in this column we will type in the type of this uh, uh, attribute. So the type of this attribute needs to be an integer, and our db object provides a class to associate that. So we will type in db dot integer. and we also pass in another property called primary key, and we will set it to true. So we have associated our ID. So we have created an attribute called ID. The next thing we want to create is an attribute called name, and this one's going to be simpler because it's just a string and it does not need to be unique or a primary key. So we will create a new variable called name and assign a DB column to it, which means we'll add a column to the database. And inside the DB column, we will pass in DB dot string. So now Python knows that name is an attribute of type string and a column and a, and a column in the table name task lists. Now we need to define a function that will get fired each time an object of this task list class is created, and that function is called, yes, you guessed it right, a constructor. If you would have followed the last video that I linked, you know what a constructor is. And to create a constructor, we will create a function and name it underscore underscore init underscore underscore. And we will we will pass in two arguments to this function, which is basically self, which means that the self variable will reference the object itself. Then we'll also pass in something called, then you'll also pass in the name, because we will be requiring the name from the user and it won't be inferred. Now you must be thinking why we are not passing ID in this, and this is because ID is the primary key and it is inferred from the last model. So uh, it is inferred from it is inferred automatically. So if you create the first task list in this table, it will get a association of ID 1, and if you create the next task list, it will get an ID 2. So we don't really need to pass the ID in the constructor. To set these functions, whenever this constructor is fired, we will just type in self dot name equals to the name we have passed from this init function. So we will save this now that we have a task list model ready. The next model we want to create is called the task model, and just like a task list model, the task model is also a class. So we will type in class name of the model, which is task, and we will tell that it needs to inherit from DB model or model in the database, and it also has a table name, which is equal to tasks. And now we have a few other attributes. We have a few more attributes in tasks, and we'll create them one by one. Task also contains an attribute called ID, and this is to identify the specific task. So this is also a column in the database, so we will type in db.column, and we will type in db.integer because it's a type integer, and this one is also a primary key for task object, so we will type in primary key equals to true. Now the next thing we have in our task model is the text attribute, and the text attribute has to be a string because it represents a line of text, which can be anything like take dog for a walk, cook food, get groceries, and all that stuff. So we will type in text, which is equal to db dot column of type db dot string and nothing else, because we don't really need to require we don't need to we really don't because we don't really need to uh, add any other constraint to this attribute. The next attribute we have in the class task is the completed attribute, and the completed attribute has to be a boolean, and it's very easy to create boolean objects in this case. So we will type in completed equals to db dot column, because this is also a column in the database, which is of type db dot boolean. That's that. The next thing we have in this tasks object is the list id, and to add the list id we'll type in list id equal to db dot column, again because this is a column in the database, of type db dot integer, because we are basically referring to this id and this is of type integer, so we need to add an integer type of list id in this task, which will associate a specific task to a specific task list. So we will have added the list id attribute. So we are done with all of the attributes for this task object, and now we need to add the constructor, which is the init function. So we will type in def underscore underscore init, and in this case, with the referencing, with the self reference, we will add a few other arguments. रुक जाओ यार. In a few other arguments, and the few other arguments will be text completed, few other argument, and the other arguments will be text and list id. Now in this case, again, we don't need to pass an id because it is inferred, and you must be wondering why we are not passing the completed attribute, and that is because we don't need to know from the user what the status of the to do is, what the status of the to do is when the to do is being created. But because whenever you create a new to do, the status by default is not completed. So in the init function, we will set the completed to false every time a new to do is created. So we will set completed self dot completed equals to false. Once that's done, we'll set other properties. Self dot text equals to the text we have passed through the init function. Self dot list id is equal to the list id we have passed through the init function. Now we have completed the creation of this database model also, and then we will save. Now that we have saved this, the next so guys, that's it for this video. If this video was, so guys, that is up. So guys, that's it for this video, and I'll be wrapping this video up here. In the next video, we'll be building all of our individual endpoints using these database models that we have created in this Flask application. So see you in the next lesson.